Okay. Good morning, everyone. Uh, what was the last topic we have discussed in our previous class? Calculation of free float, is it right? And was it the first or the second problem on free float? This is the third problem, is it right? That means this is the last example of free float. And did we complete that problem?
No, sir.
Okay, so we have not yet completed, is it right? Okay. All right. So in that case, we have not completed the last problem, is it right?
Yes, sir.
Correct. Okay. All right. So first we'll complete that and then we'll go for the next topic. Just to recall what free float was, free float was nothing but the project manager is going to assume that the current activity is going to finish as soon as possible. The next activity is going to start as soon as possible. Okay. So with this type of assumption, the project manager is trying to determine what is the total delay available for each stack. Just to quote one example, purchase of the raw material can be one of the activity. And once the purchasing of the raw material is complete, we can start hiring the employees for building construction, or the workers for the building construction. So the project manager, it may so happen that purchasing of the raw material may happen at its earliest date. That means as per the schedule, correct? And it may also happen that uh, the project manager expects that the next activity, that is hiring of employees, start as soon as possible. Correct? Now, considering this as the scenario, the project manager tries to determine the total float or the total delay available for. Okay, that is the case. So possibly we are in solving the second problem. Okay. So can you just dictate that particular problem which we are supposed to solve? Possibly the column headings were activity, and the duration was not there as per what I remember. Early start and early finish. Okay. So just tell me the list of activities.
1 to 2,
Okay.
2 to 3,
Okay.
3 to 4,
All right.
4 to 7,
Okay.
2 to 6,
2 to 6. Okay.
6 to 7,
6 to 7. More activities there.
7 to 8,
7 to 8. All right. Yes. List of early start.
0,
Okay.
10,
Okay.
35,
Okay.
60,
Okay.
10,
Okay.
12, 90.
19. 90, I guess. Is that right?
90, sir.
Correct. All right. Now about the early finish.
10,
Okay.
35,
Okay.
60,
Okay.
90,
Okay.
12,
Okay.
14,
14. Okay.
92.
How much? 92. Okay. All right. So just tell me the free floats that we have calculated.
Zero,
Correct. One is 0. Next.
35 minus 35 is equal to 0.
That is also 0. Correct.
60 minus 60 is 0.
Correct. 60 minus 60 is 0. Correct. Next.
90 minus 90, 0.
90 minus 90 is 0. Correct.
12 minus 12 is 0.
12 minus 12 is 0. Correct. Next one is also 90 minus 90. That is 0, I guess. No.
Yeah,
Is it right? The next activity? No. It should be
so we
something
stop
else.
till there. Then,
Okay. 6-7 and 7-8 are remaining. Is it right?
yes, sir.
Correct. So 6-7 activity. Yes. Is it right? So I want another opinion on this. So we have completed until this. Is it right? Free float
Yes, sir.
calculation. These many calculations are over. Is it right? Any other student?
Yes, sir.
Okay. I'm just asking this because it should not happen that one student may have solved some more activities and because of which the calculation may be missed. That is the reason I'm just asking another student's opinion. Okay. All right. So this is done. Now two free floats are still remaining. Uh, so we are supposed to calculate the free float for 6-7 activity. 6-7 activity. So 6-7 activity. This is the present activity. What is the next activity after 6-7? What comes next?
7-8.
Correct. 7-8 will be the next, right? So what is the early start of 7-8?
90.
90. And early finish of 6-7?
14.
14. So therefore, free float for 6-7 activity is equal to how much?
76.
Correct. 90 minus 14, which is equal to 70. That's right. Okay, so this is the free float for this 6-7 activity. One last activity is remaining, and that last activity is 7-8. Okay, 7-8. So how do we calculate 7-8 free float? Because there is no next activity. After 7-8, there are no activities. So in this case, okay. Why 0?
Because after 7th activity, after 8th activity, there is no activity, sir.
No activities, correct. So what will be the early start for that activity? What will be the early start of the activity that starts from the 8th node? Okay, so since there is only one activity that finishes on the 8th node, so that value, the early finish value itself will be the early start for the next activity. Okay. Otherwise, in the previous problems, we had considered the maximum value. Let us assume that if three activities finished on the 8th node, then we had considered the maximum early finish. Okay. So next we have 7-8 activity, that is free float for 7-8. Okay, 7-8 activity. So this is 7 and this is 8. What is the early finish for 7-8 activity?
92.
92. Correct. Now, this is the present activity. This is the present activity. Correct. The early start for the next activity is equal to early start of activity that starts from the 5th node. That starts from the 5th node. All right. So the activity that starts from the 5th node will be the activity the next activity. Okay. Therefore, early start of the next activity is equal to early finish of 7-8, which is equal to 92. So in which case it will be 0. In which case the free float will be equal to 0. Okay. So if there is any doubt, you can ask. Okay. So this is how we calculate. So in this case, the free float value will be equal to 0 because it will be equal to 92 minus 92. Answer is going to be 0. Okay. So if anyone wants me to go back to the previous screen, just tell me. So this is the final solution of the last problem. Okay. So 92 minus 92, which is equal to 0. Okay. So next topic, we are going to discuss the independent float. The independent float. Here, the parameters which are considered for independent float is slightly different from what we considered in the free float calculation. So if anyone has not understood the previous problem, you can just ask. Otherwise, I will go to the next. Or if anyone has not made note of any of the points in the previous screen, just communicate the same to me. Okay. So in which case, I will go for the next topic. So this is another type of float that is called as independent float. Independent float. Okay. So let us consider one example. Okay, and then we'll try to understand what exactly is the independent float. Okay. So can anyone tell me the example in which we have the following columns: activity, duration, early start, and late finish. Okay. So just tell me the problem or dictate me that particular problem in which we have either solved for early start and late finish, or the problem definition had activity duration, early start and late finish. So just dictate me that particular problem in which we had these four columns, or for in which we have solved for early start and late finish.
One dash two.
Okay. How many activities are there totally?
6.
6. Okay. I think we'll just consider 3 out of 6. Okay. 1 dash 2.
2 dash 3.
Correct.
3 dash 5.
3 dash 5. Okay. This is sufficient. Now about the duration.
14.
Okay.
7.
Okay.
20.
Okay. Early start.
0.
Okay.
14.
All right.
14. 21.
Okay.
21.
This is 21. Yes.
21.
That's right. 21
41.
and 41. All right. So we'll write the questions written in the same screen. Okay. So the question is, determine the independent float. Determine the independent float for activity 2 dash 3. Okay. So for this activity, we are supposed to determine the independent float. Okay. So this is the question. So while solving this particular problem, we'll write certain explanation and we'll see that this concept is understood. Okay. So basically, if you have to see, the project manager is considering different type of parameters and the delay is being calculated. Okay. All right. So this is the problem definition. I hope everyone has made note of this, and I'm just going for the next slide. Next. Um, okay. So we are supposed to determine the independent float for 2 dash 3. This is the 2 dash and 3 dash and 3 dash 5. Okay. So as like in the previous example or the previous calculation, we will just try to identify which is the present activity. This is present activity because for 2 dash 3, we are trying to determine the independent float, and the next activity is 3 dash 5, and the previous activity is 1 dash. Okay. So these are the 3 different activities. Now we'll define what is independent float. Independent float is equal to early start of the next activity, early start of the next activity minus, okay, late finish, of the previous activity. Yes, so I think next activity, if you just mention that Next activity is 3-5. Next activity is 3-5. The late finish of the previous activity. Previous activity was 1-2 minus duration of present activity. Duration of the present activity. Independent float is equal to early start of the next activity. So next activity is 3-5. So just make a small correction here. The next activity is 3-5. Or you can just write it in the bracket after you have written next activity. Small brackets, you can just write 3-5 activity and close this bracket. Now next is minus late finish of previous activity. That is 1-, correct? So this is 1-2. That is the previous activity and duration of the present activity. Present activity is 2-. Okay. Now it is very much understandable that. Okay. Just we'll go one more step ahead and we'll just consider one more example here. Okay. Let us assume that this is purchase of the raw materials. Purchase of the raw materials. And this is hiring employees. Hiring of employees and then start manufacturing process. All right. So what we are trying to assume here is that the manufacturing process will start as soon as possible, and what will happen is purchase of the raw materials may be delayed. Correct. So if you have to see, due to this pandemic or maybe a number of reasons, maybe that may be a government employee strike, the KSRTC strike, or the transportation vehicle owners strike, correct? Because of which the supply of the raw material may be delayed sometimes. Okay. So what will happen is that activity may be delayed. So this activity may finish as late as possible. There is a possibility, right? The first activity may delay, because of which the next activity may have to be done on time. Otherwise, what will happen is all the activities, if they go on delaying, the project completion duration will be delayed. Okay. Project manager has to see that project completes on time. All right. So this activity is assumed to start at the earliest. Okay. And this activity is assumed to finish at the latest possible duration. So under this circumstance, what is the total delay available for this activity which you find it in between? Okay. That is 2-3. Yes, is there any doubts here? How to formulate the equation for the independent float? Any doubts? Small adjustment we are supposed to do in terms of the formulation of equation. For free float, this component remained the same. If you have observed, the early start of the next activity, we are going to consider even in the early free float calculation. Early start of the next activity, we are going to consider uh, in the free float calculation. Okay. Next is late finish of the previous activity. Late finish of the previous activity. Late finish of the previous activity was being replaced with early finish of the current activity. That was something, the change which you found in the previous calculation. Okay, so you can just make note of this, and those of them who have some doubts can just ask. Okay. So I'm just going for the next screen. We are supposed to determine the uh, independent float for. So independent float for activity 2-3 is equal to. So what is the independent float for activity 2-3? So first we require early start for the next activity. Next activity is 3-5. So what is the early start for 3-5?
21.
21. Next is late finish for the previous activity 1-2. What is the late finish for the previous activity?
14.
Okay. And what about the duration of 2-3?
7.
7. Answer should be
0.
0. So this is calculation. Now interpretation. Project manager assumes that the project manager assumes that the project manager assumes that the next activity will start. The next activity will start as soon as possible, as soon as possible, and the previous activity finishes, and the previous activity finishes as late as possible. Okay, so this is the interpretation, and under this assumption, the project manager actually determines the independent float. Okay, so this is the basic interpretation. Okay, anyone wants me to stay back in this particular screen? Yes, if everyone has made note of this, I'll go to the next one. All right, so just dictate me. Dictate me that particular problem. That is 1-2. Sorry. We have activity and duration, early start, and late finish. All right. So just tell me the list of activities. How many activities are there?
6, sir.
6. Okay. Tell me one by one. Activity column. 1-2,
2 to 3,
2 to 3.
3 to 5,
Correct. Next,
2 to 4,
2 to 4. Okay.
4 to 5,
4 to 5.
2 to 5,
Next, duration. Sorry, not
14,
due. 14 should have been the duration. Okay. Yes.
7,
7.
20,
How much? 3-5 is how much?
20,
20. Okay.
4,
4. Okay.
15,
Okay.
12,
All right. So, about the early start.
0,
Okay.
14,
14. Okay.
21,
Okay.
14,
Okay.
18,
18. Okay.
14,
18 and 14. Next, late finish.
14,
Okay.
21,
21. Okay.
41,
Okay.
26,
26. Okay.
41,
41.
41,
21.
41, sir.
Again 41. Okay. So for this problem, we are supposed to determine the independent float for all the points. Thank you. So for this problem, we are supposed to determine the independent float for all these activities. Just make note of this. This is already solved the previous problem. Somewhere we have solved in our previous class. Same values are being considered. So just write the question statement. I do not have space here. I'm not writing the question statement. So you can only write the question here. Determine the independent float for each activity. Determine the independent float for each of these activities. Determine the independent float for each of these. Okay, so I believe everyone has made note of this. If anyone wants me to come back to this particular screen, you can just tell me. For now, I'm just going ahead. Solution for the first activity. Independent float. Independent float for 1-2 is equal to, we have 1-2. What comes after 1-2 activity? What is the next activity?
2-3.
2 dash. Only one activity, is it right?
No, 2-4 is also there.
Okay. But it doesn't matter. We consider even only one activity. That is also fine because the early start will not change. So what is the early start for 2-3 and 2-4?
14.
Correct. So these two are nothing but the next activity. These two are the next activity, and this is the present activity, and there is no previous activity. Okay, no previous activity. So in which case we are going to start. We are going to consider. Okay, therefore the latest finish is equal to 0. There no previous activity is there, so that is the reason you can say that the no previous activity is there, so that is the reason you can say that latest finish is equal to 0. So no previous activity, therefore latest finish is equal to 0. Anyone has any doubts here? So in this case, can you calculate the independent float for the first activity? Or is there any type of doubts here? Has anyone not understood this? I can explain this once again. So just make note of this, and after that we will go ahead. Okay, so I'm just going ahead. Independent float. Independent float for fund is equal to early start for the next activity minus date finish for the previous activity minus duration of 1 dash. Okay, so what is the early start for the next activity? What is the value?
14.
14. And what is the late finish for the previous activity?
0.
Duration of 1 dash 2?
14.
Answer should be
0.
right. That means assuming that the next activity will start as soon as possible, and assuming that the previous activity finishes as late as possible, the total delay available for this activity is 0. Okay. This is the solution for the first problem. You can just make note of this. And what I remember is I have forwarded some of the online class, the link to the previous online classes I have conducted. Those of them who have missed the class due to several reasons, they can just use that link and see that you are preparing for the first session. Okay? No matter there is a final examination or not, we do not know what it is, right? So, but see that you are preparing well for your first session and consequently for your semester end examination. Okay, and it is very much important that you maintain the internal marks. So, unfortunately, see that unfortunately it should not happen that the internal marks is less. Correct. Then we cannot help as a faculty. Even I cannot help in any manner. Correct. See that you are preparing well for your first sessional. First sessional is very much important. I think by now you may have realized it. Correct, after your first semester. So see that you are taking first sessional very much serious and preparing for it. Download the online classes which I have uploaded in the YouTube and start preparing. If you have any doubts, you can ask. Correct. So until now, I have not announced the first sessional date, but somewhere around 20th onwards, okay, just near to 20th of this particular month, 21st or some date, okay, I will just announce the first sessional so that you are preparing for the first session. Okay, so until now, I have not announced the sessional date, and also I have not announced the activity for the group assignment. Okay. So group assignment will be clarified only after this particular topic is finished. All right. Okay. So if there is any doubts, you can ask. Otherwise, the class is over. The class here can just send me the list of absentees.
Okay, sir.
Okay. Thank you. Thank you, everyone.
Thank you, sir.